Hello and welcome to my YouTube channel. I'm just going to put my name here so credit goes to me, and any copyright issues also go to me. So going forward, it says considering the following instruction. Okay, so it gives us an instruction, and that instruction is and some destination register, and then the two registers we're ANDing together, and this is within RISC-V. Okay, and this here is the RISC-V hardware that we're going to go over. Okay, so to begin, this is important going forward and just for fundamental first principle understanding of what is actually happening. This is some instructions within the instruction memory, okay? And it's going to have a PC that labels it or tells the instruction memory where these instructions are, okay, within the instruction memory. So the PC counter basically tells the instruction memory what instructions to get, and that's what the PC counter does. Now going forward, let's break this down. So since it's an AND, we know AND is an R type. So AND is R type, okay? And what R type does is that you're gonna have two registers. So you're gonna have this register as register 1, okay? It could be something like, for our sake, we'll call it X13, okay? So this now is X13, excuse me. And this can be X12. So read register X12 or read register 2 is X12. Now those two registers are going to have some binary integers, or it's just going to have some binary bits there, and it's going to go in here and it's going to go in here. Okay, so that brings us to what it brings us to what we are using and what we are not using. Basically, we're answering the first part of the question. What are the values of the control signals generated by the control in below figure for the instructions? Okay, so we have these two binary bits that they're going along, they're having a merry little way, and they're going to go, well, the X13 is going to go straight into the ALU, but notice register 2, it goes to this mux, okay? And what else goes to this mux? Well, the immediate generator, okay? Now, normally, or the one specifically that you guys are reading, has a 0 and a 1 here. So notice that it's blue here, so we have a control signal there. So we can go ahead and we'll write over here ALU SRC. It wants to choose either 0 or 1, so we're going to pass a 0 there because we want to read register 2's data. So we're going to pass a 0 in there, okay? And that is going to allow for the X12 register to simply pass and go straight into the ALU, okay? So our ALU, that's going to be 0, false, I believe is in the answer, something like that, okay? And that's what's going to go. And that's what's going to allow the two registers that we're ANDing together to go to the ALU to be able to be ANDed together, or the operation to be committed to the two registers. Okay, so let's go forward. ALU operation, because we have another blue signal, and then we have this 4 with the strike. So there's going to be 4 bits from the control unit going into this ALU, okay? So we know that there are 4 options, okay? So we have option that we want, since it's AND, the AND operation is going to be 0, 0, 0, 0, okay? But there's other ones. So this is AND. Now there's OR. So we got 0, 0, 0, 1. That's if this was an OR. So if this right here was an OR, then that is the instruction we would want. Then there's also add, which is 0, 1, 0. which is add. So this is for stuff like load, store, add. That's what the ALU is doing. It's adding the two things together. So you'll want to know that. And finally, you have subtract. So this is for stuff like branch, if equals, or branch not equal, or if this was subtract right here. Okay, and this is subtract. So this is important. He said he might give it to us, but we don't know yet. So that's the first question. Well, now we can continue on our sweet little way. So after this, we're gonna have x13 and x12. So we're gonna go over here. Okay. What we must ask ourselves is, are we wanting to store the ANDed value in the memory? No, we do not. So both memwrite and memread are going to be 0. So memwrite, because we're not writing to the memory, is going to be 0, and we're not reading from the memory, so it is also going to be 0. Now, since we just bypass the memory, we're going to go all the way down here, and then we're going to go up to this mux. This mux usually has a 1 and a 0. Okay, so this is going to be 0, and this is going to be 1, and again we have another signal. It's called mem to reg. So we're going to have mem to reg, and again, since we want to select the result of our AND operation from the ALU, we're going to want to select 0 or false, as the answer says. Okay, now we go all the way back. This is the importance of the destination register. So we take this long winding road all the way back to the write data. And yes, we are going to want to write on our destination register, and because of that, we are going to have reg write. So reg write is going to be enabled. Now, I understand that the answer has reg write as the first answer, but really what's happening is it's allowing this mem to reg, or the write back phase, to write back to the register data. Okay, so going forward, which resources or blocks perform a useful function for this instruction? So we know that it's an R-type instruction, so it doesn't use any data. So essentially, to answer this first part of the question, I'm just going to highlight what we have used, and that is basically going to be our answer. So let me get out a nice color for the highlighter. Well, since we've been consistently using blue, we'll use blue. Okay, so we did use the register, so we're going to highlight the register. So we did use that. Now remember, our data went through here and through here, so we also used our mux to control between the immediate gen and the register data. So we used that. And next we have the ALU, so we also use the ALU, right? Going forward, we went along this path, remember, and we used this mem to reg mux. Okay, so essentially what the answer for part B is, we're going to say we used the registers, we used the ALU source mux. We also used the ALU itself to compute the AND operation. And finally, we used the mem to reg mux, period. And question C is, which resources produced no output for this instruction? Which resource produces, or which resource, oh my goodness, can't English right now. Which resources produce output that is not used? Okay, so keep in mind that everything is, like, for example, when we get our instruction from I should use a different color. So when we get our instruction from here, there's going to be values sent everywhere. So there's going to be values sent to the immediate generator, but that's why we have the mux, so we can choose between the value that the immediate generator produces, or we can choose between the read data, right? So everything within this hardware is always computing and having some output, but because of these muxes, we choose which data that we accept to use, okay? So this is important to understand, or this is what this question is trying to bring home to us. So for example, the immediate generator and the data memory both produce useless information, period. I think that's what the answer says, something like that, right? All blocks produce some output, the output of the data memory. I mean, yeah, basically the same thing. So that is question. Like, comment, subscribe.